This video is for those of you who want to understand functions. So in this tutorial, we are going to talk about relations and functions, basics of the functions, inverse functions, composite functions, quadratic functions, domain and range of the function, piecewise functions, odd and even functions, polynomials, rational functions, modulus functions, and radical functions. So let's begin our discussion with relation and functions. What is a relation? Basically, when we're talking about relation, we're talking about a set of pairs of input and output values. Now, when we're talking about the input values, what are we talking about? The input values, these are the x values. Okay, at the same time, this is the domain. So we are saying that this is the pair of the input and output values. So when we talk of the output values, these are y values. Okay, then at the same time, this is a range. So whenever you hear to say domain, we're talking about the x values. The range, we're talking about the y values. Okay, now from here, let's get started. Let's say we have got a function, to say a set of function 1, 4. Then we have 3, 4. Let's also have 7, 3. Okay, so as you can see, the first part here is our x value. This is y, this is x, this is y, this is x, this is y. Now they can ask you to list the domain. The domain in this case is going to be, so we start from ascending, so it's going to be 1, comma, we're going to have 3 and 7. So this is our domain. Okay, what of the range? So the range of the values in this case, we're going to have 3. We start from 3, then we're going to have 4. We only have 2. So this is our range. Okay, now how can we map this? We can see that the x values, the ones we are calling them as a domain, we're going to put them here. We're going to say that this is x and then this is y. So to map them, we're going to say that we're going to have something like this. Then we're going to have something like this. So we put the values here. We can see that we're going to have the x values, we've got 1, 3 and 7. The y values, we have got 3 and 4. Now let's see. 1 is mapping to what? 4. So we're going to have 1 all the way to 4. So it's going to come from here all the way to 4. Next we have 3 to 4. 3 to 4. Okay. Next we have what? We have 7 to 3. 7 to 3. Now, is this a function or not a function? So this is a function because all the values of x, they are mapping to the values of y. Okay? So now, in short, for us to consider a function or a relation to be a function, all the input values must have an output value. Then we are going to call that one as a function. Not only that, but we should also note to say there should be only one output for each input. Okay? So for each input here, I need to have only one output. Perhaps you have seen some equations which maybe we have got this. Okay, is equal to 0. It's possible we can find two values of x. Perhaps we have seen maybe x is equal to plus or minus maybe 2, meaning we've got x is equal to 2, x is equal to negative 2. Okay, you can have two values of x mapping to one value of y, but it is not possible of you having two values of y mapping to one value of x. So once you see to say one value of x is mapping to two values of y, that is going to be wrong. That is not a function. Okay, for example, let's say we have a function. Let's have this. Let's have this. Let's see if this is going to be a function. Let's say we have 1, 2. Then let's have 1, 3. Let's have 2, 3. Let's see if this is a function. We are saying that for us to consider something to be a function, all the input values must have an output value. meaning that all the element of x, they are supposed to have the output value. At the same time, there should be only one output value for each input. Okay, so we have got 1, we also have 2. Then the output values, we have 2 and 3. Let's see. So 1 is mapping into 2. At the same time, 1 is also mapping into 3. Then 2 is mapping to 3. Now we are saying that we can have two values of x mapping to two different values of y. Okay, we are saying that we can have two values of x mapping to one value of y. That is just okay. Okay, but it is not possible of having two values of y mapping to one value of what, of x. Okay, so as we can see here, we cannot call this one to be a function because one is having two output. It's not possible that we have the input value. It's not possible that the input value can have two output values. So we are going to say that this is not a function. Okay, so now from there, let's also talk about one-to-one function. So let's say we have got a function. Let's have this. Let's also have this. Let's say we have 1, 2, 3, 4. Let's have 3, 4, 5, 6. So let's say 1 is mapping to 3, 2 is mapping to, this is mapping there, this is mapping there. So we have got x and y. Now what you need to understand here is very simple and straightforward. So this is going to be a function because each input value has got an output value. At the same time, each output value is only mapping to one values of y. Then we can say that this is one-to-one. This is one-to-one function because only one element of y is going to one element of x is going to one element of y. 1 is going to 3, 2 is going to 4, 3 is going to 5, 4 is going to 6. So this is one-to-one function. Let's have another one. Let's say we have a different one. Okay, let's say we have 0, then we have 1, we have 2, then let's have also -2, although I was supposed to start from here. This is going to be -2, 0, 1. Then we're going to have what? We're going to have 2, just like this. Then let's have 0 here, let's have 1, let's have 4. Now let's say that this is mapping there, then at the same time 0 is mapping to 0, 1 is mapping to 1, this is mapping to. So this, perhaps this is a function. Okay, let me redo it. We say this is mapping to 1, but 0 is mapping to 0. Okay, it is possible that two values of x can give us one value of y. That is just okay, but it is not possible that one value or two values of y giving us one value of x. It's not possible. So here we can see that this is going to be a function, but this function, what type of the function is this? This is many to one. Okay, many to one. Why are we saying many to one? Many values of x are going to one value of y. As we can see, -2 and 0, they are going to 0, only 0, meaning that it is many to one. So two values of x, they are going to one value of y. That is, it is a function. And what type of the function? It is many to one. Okay, then there's also what we call, let's have this, a different one. We see what we're going to have. Let's say we have 1 here, let's have 9, and let's have a 0. Okay, then this side, let's have also a different one. So we're going to have 1 here, we're going to have 3, this is going to be -3, 0. So let's say that 1 is going to 1, then 9 is going to 3, at the same time 9 is going to -3, then 0 is going to 0. Remember, we said that we cannot have two values of x of y going to one value of x. So this is not a function. 1 is not a function, 2, this function, as we can see, it is one to many. It is not a function, but it is a one to many function. Okay, why are we saying it is one to many? We can see that one element of x is going to two values of what? Two values of y. So it is one to many, but it's not a function because we have got one element of x which is mapping to two different element of y, which is not possible. Okay, it's possible we can have two element of x going to one member of y. That is just okay, but not one member of x going to two members of what? Of y. That is not going to be a function. Okay, so now let's say we have a different one like this. So we have 1, let's have 2, let's have 3. Next, let's have this. So let's say that this is a, this is b. So we have 4, 5, and then 6. Let's say that 1 is going to, this is going there, then this is going there. At the same time 3 is going there, at the same time 3 is also going there. So as we can see, one element of x is going to two elements of y, or one element of a is going to two elements of what? B. At the same time, two elements of a, they are going to one element of what? B. So this is not a function. It is not a function because one element, okay, two element are going to one element of a is giving us two different element of what? Y, which is not possible. Okay, so now we can say that this is many to many. This is many to many, but it's not a function. Okay, now let's say you have this. So let's say this is x and then this is y. Let's have a, b, c. And then here we have capital A, B, C. Now let's say this is going here. Okay, then this is going there, it's also going there. So we can see that this is not a function. One is not a function because two element of y, they are giving us one element of x, one, and at the same time all the elements of x, they are supposed to have an output. So this is supposed to be mapped. So if you have got any element which is not mapped to anything, as long as that element is in x, then that is not a function. Okay, what if I change this, then I put it like this? Okay, I put it like this, or we say this goes here, then again this one goes there. So this is going to be a function. It is possible we can have all the element of x, which we can see that the input has got an output value, but still we have got one member which is not mapped. As long as that member is in y, then that is just okay. But we are supposed to have all the element in x, they are supposed to be mapped. So all the element of the input values, they are supposed to have what? The output. But it is possible that the output cannot have the what? The input. That is just okay. So we can consider that one to be a function. Okay. So now let's see how we can solve this. We have got this question which is saying find the domain and range of each of the following function. So let's start with the function or the domain. So the domain in this case, we know that these are the x, so we're going to start with getting from the ascending order. We're going to have 0. So we start from 0. From 0 we have 3. 3 we have 5. 5 we have got 8. 8 then we have got 9. So this is our domain. Okay, what is the range or the function f? The range is 1. 1, then we are going to have 4. 4 we are going to have 7. 7 we are going to have 11. 11 we are going to have 12. That is our range. Okay, so go ahead and find the domain and range for the function g. You can pause the video and find the domain and range. Okay, so there we go. So the domain in this case is going to be, we're going to start with negative. We're going to start with the one which is the lowest, which is 10. We've got 10, 20, 30, 40, and 50. That is our domain. Okay, so what is our range in this case? The range, these are the values of y. So you can see that we have got this, this, this here, we have this, we have also this. So that is our range. So we can list the range here. We can see that our range is going to be -4, comma 6, or is comma 1. We have got 1, comma 1, comma 6, comma 9. Then we have got comma 13. So this is our range. Okay, so that is it for question 1. Now the next question is saying, which of the following set of ordered pairs represent a function? So let's see, we have got the first one. So the first one, we can see that we're going to have, so allow me to put x and y. So I'm going to do this. Okay, that is what we're going to have. We also have this. So what is our x? Our x, we have got 1. That is the domain. I'm getting the first part here. So I'm having this one, this one, this one. Okay, so I'm having 1, 3. Okay, I'm having 1, 3, and what? And 7. The y values, we have got a 4, and so we start with 3. We have got a 3 and a 4. So let's see. 1 is mapped into what? 4. So 1 goes to 4. 1 going to 4. We put even arrows. Then 3 is going to 4. 3 is going to 4. Okay, 7 is going to 3. 7 is going to 3. So is this a function? Yes, it is a function. 1, because all the input values have got what? The output values. Next, we can see that only one input value is having what? We need to have only one input value. For every input value, we need to have the output values. Okay, that is the first point. Then the next point, we can see that it is okay, we can have two different elements of x. They can go to one to the same element of y, but it is not possible as having two different elements of y going to one element of x. Okay, so this is a function. Okay, so let's go to part B. We go to part B, we see if that is a function. So we're going to have also x, y. We have this. We have this. What values do we have? We have got 1. We have got 2. That's all. Then we have got 3. And then we have got what? We have got 2 and 3 here. 2 and 3. So we can see that 1 is mapped into 2. Then 1 is mapped again into 3. 2 is mapped into 3. So one value of x is going to two different values of y, which is not correct. So this is not a function. So only one value of x is supposed to be going to one value of what? Of y. Or two elements of x can go to one element of what? Y. That is just okay. And not one element of x mapping to two different elements of y, meaning that is not a function. Okay, so let's see, we have question 3 here, which is saying let set a to be equal to. So we're going to be using that. We have been given a and b to be equal to, okay, we have got 0, 1, 2 and 3. Then the b is -2, -1, 0, 1, 2. Now the first point here, they are saying which of the following set of ordered pairs represent a function from a to b. So the first point, which is part A is 1, 0. So 1, 0 is going to be, we start from 1 all the way to 0. So where is 1? We have got 0, 1. So 0 here all the way to 1. Next is 1 and -2. So 1 here all the way to -2. Next is 2, 0, 2, 0. Okay, let me redo that one. 2, 0 is here. Next is 3, 2. 3 all the way to 2. So is this a function? We can only consider to say it's a function as long as all the values of x, all the values of a, they have got an output value. Okay, so as we can see, even if this one is not mapped to anything, but as long as all the values of x, they have got the output values, then that one is going to be a function. Then one value of x cannot go to two different values of what? Two different values of y. So as we can see here, all the values here, each value has got just one output here. So we are going to consider this one to be a function. So part one, we are going to say this is a function. Okay, so let's go to part B. I'm going to use the same one. Part B is saying we have 0 comma negative 1, 0 comma negative 1, then 2 comma 2, 2 comma 2. Next we have 1 comma negative 1 comma negative 2, 1 comma negative 2, that one. We have 3 comma 0, 3 comma 0, 3 here comma 0. Next we have 1 comma 1, so 1 here comma 1. So this element, which is for a, this element is giving us two different values of y, meaning that this is not a function. So this is not a function because one element of a is giving us two values. So one input is giving us two output, which is not possible. So we say that there should be only one output for each input, as simple as that. So this is not a function. Let's go to the next one. We go to part C. Is part C a function? Let's see. We have got 0 comma 0, 0 comma 0 is this point here. Then you have got 1 comma 0, 1 comma 0 is going there. Then 2 comma 0, 2 going there to 0, that is just okay. Then 3 comma 0 again, this one going there, that is just okay. So is this a function? So this is a function, yes, because all the output values or all the input values, they have got what output value. So we said that there should be only one output for each input. So we can see here that this input here has got the output, this one has got output, this one has got output. So this is we're going to call this one as a function. Okay, perhaps you have seen equation which is starting x to the power 4. You can have 4 different values of x giving us one value of y. So this is a function. Let's go to part D. So part D is 0 comma 0 comma 2, 0 comma 2, which is there. Oh, it's 0 comma 2, not negative. 0 all the way to 2. 1 comma what? We have next is 3 comma 0, 3 comma 0. So my 3 is here comma 0. Next I have 1 comma 1 comma 1, 1 comma 1, that is just okay. But all the outputs all the input values, they're supposed to have the output value. So as we can see, this input here has got nothing. It's not mapped to anything, so this is not a function. Okay, so this is what we need to know under relations and functions.